All right. I'm here to introduce Miss Cindy Yen. She is a first-generation Chinese American. Her parents moved from South China to the U.S. in 1984, seeking better opportunities for their future family. She and her brother were the first generation to attend and graduate college. She graduated from the University of Washington in '08 with a BS in chemical engineering. Looking back through the last 9 years of her career, she believes that she's been fortunate enough to receive opportunities that made possible by engineering. She first started working as an ultra-pure water engineer and then integrated chip fabrication engineer from '08 to 2013. Then she started working for a series of startups growing 90 kilograms of sapphire bulls, and then making quantum dots in 2014. She currently works at Boeing as an equipment reliability engineer since 2015. Please give a warm welcome to Ms. Yan.
Hi guys, so I'm excited to be here today. I hope you guys are too. How you guys doing? All right, doing great? Staying awake? All right, so are you guys juniors? Are you guys seniors? Can I get a poll? Okay, freshmen, raise your hand. Okay, good. Sophomores? Wow, all right. Juniors? Okay, a little bit. Seniors? Okay, all right. So a little on the younger side in the spectrum, so that's good. Are you guys excited about tech and I guess engineering? Can I get a raise of hands? A little bit? Okay, about slightly under 50. Are you guys interested in engineering or science? A little bit. Okay, so we're on the fence. Okay, so let's just get into, I guess, aerospace and engineering, and rest assured, we'll circle back to the science and engineering part, because I'm sure that you can already tell that I'm a little biased, but that's just me. There's like plenty of opportunities. So I am a equipment reliability engineer at Boeing. I started in 2015 when I got a program startup experience to establish their reliability program. So let's just go more into, I guess, aerospace and engineering, and then we'll give you guys an overview of, I guess, Boeing as a company, a little bit about the Portland fabrication site, and we'll talk about machining and how cool it is. And then we can talk more about me after. So what is engineering? Engineering can be defined as the application of scientific knowledge to practical problems, which I love because for me, when I was in academia for a little bit, papers were nice, studies were cool, but I felt like I wasn't applying things and doing things, so I felt like engineering was pretty awesome because there's lots of funding. There's a fast-paced schedule, clear deadlines, and you'd be asked to do really cool things like, how do I grow sapphire in a sustainable way so I can put it in an iPhone? Or what is shatter resistance, because it's the second hardest material known to man, which means that a phone will not shatter. It means that you'll get resolution clear enough to scan your face or do a thumbprint scan, or it allows imaging quality to be clear enough to be one of the most competitive phones available. So those are some basic application questions. And then you time that with product release, such as, how do I start a factory in time to meet a 2-year product schedule in order to release this phone or the iPad? And so I always thought that that's really cool, that's really fast-paced, I can get a lot of cool stuff in. But back to what is engineering, science allows us to gain an understanding of reality, human nature, and the universe. Engineering allows us understanding to come to life through problem solving, designing, and building things. So I cannot emphasize enough, like where that creativity could take, the future. The previous speakers have talked about software platforms, programming, and I think all of that's integrated with some type of product and service, because we've seen great applications like WhatsApp, Snapchat, Uber has revolutionized ride sharing. So I would encourage creative thinking into new solutions into reality is the current market that exists. and understanding the trends in the future and where your passion is for where you want to be. So let's talk about the Boeing Company. Have you guys all heard of the Boeing Company? Raise of hands. All right, that's good. So Boeing is a Northwest original company, and they do a lot of things to continue to encourage and establish growth in the Northwest, as you understand from the Seattle, Everett, Renton, Auburn programs, which is awesome. And they have a really good culture where the recruiting happens, with established relationships, local universities. They try to minimize their footprint whenever possible, sustain jobs. So as you can see here, it's a global company essentially divided into two different areas. We have commercial planes, which is called BCA. And within commercial planes, there's various plane programs. As you've heard of, there's 747, 737, 777X, which is always the new, most exciting planes that people want to sit in and be like, this is awesome, this is luxurious. I can watch TV on this screen, I can recline. So, that portion is always important. And within Boeing commercial airplanes, we have fabrication, which means making of the parts to assemble to go into the planes. And we have supplier management, including managing the suppliers that we bring in externally to manufacture some of the components for assembly. And we also have Boeing Defense and Security, which is BDS, and that involves military aircraft, drones, which is a new acquisition, Phantom Works, satellite systems, network and space systems involving the space program, satellite launches, which is always cool, and the global services and support for that. And I'm just gonna quickly go to a video so you can get more excited. Everyone here, yeah? It's a 3-minute video. I'll cut it off when it gets to the boring part.
Our company is one that's based on using technology and innovation to create new capabilities for our customers.
And I think engineering is very creative in its core. I'm not just studying something, I want to do something new and create something new.
As engineers, I think 30% of your job description is to worry. And then the balance of that hopefully is filled with curiosity.
The path hasn't been written, so we can have a crazy idea or something new that we want to try, and we just go in the lab and try it.
Getting people involved at a very fundamental level creates a very fertile soil from which these incredibly great ideas can be born.
We're far thinkers, right? We go and do something and we think, well, how can we do it better? It's a blast. It's some of the coolest stuff.
I think when you get good creative people together, I've yet to see a challenge that Boeing employees can't solve.
The aircraft industry is facing great environmental challenges, and every little thing we do helps.
I have 2 boys. They drive by the factory. They go, Dad, is that your office? And I go, yep, that whole building is my office.
I was a Navy pilot and I was an astronaut. I mean, I used products that other people built. So here I was given the opportunity to put your fingerprint on the new spacecraft.
Here at Boeing, you make history. You build the future.
We're at the forefront of bringing this technology to a number of different applications that will make life on Earth better for everybody.
The wing is nothing more than a giant sail. So this wing being so long creates more lift. This airplane loves to fly.
We've taken the best minds and we've built something that I think will really help humanity.
Today, somewhere in the world, the person who's going to be the first person to set foot on Mars is out there, probably studying math or science.
I want to see the first launch. I'd be so excited to shake the astronaut's hand and tell him that I worked on SLS. I get kind of emotional about it.
Our
our products touch so many aspects of life, and to be able to have some kind of influence, however small. People have to want to do this as part of who they are. There's an obligation to learn something every day. When you're making the world better and you get to work on those things that you dreamed about working on when you were growing up as a kid, there's just no better job in the world.
videos. The first was an intro going into like the different types of functions in Boeing. You know, you could be a scientist working on the next phase of biofuels. You saw a massive molten forging of titanium from Russia that's exported to the Portland site, you know, for metal machining. You know, there were some engineers talking about how they're designing the next generation of aerospace, you know, craft, and, you know, redesigning, you know, the engines of a plane to be more fuel efficient with the latest GE turbines, for example, or GE engines. So that's all pretty cool stuff. And also, you know, working with people who are passionate about what they do, and really wanting to engage in great products that affect people or could benefit society, which is always awesome. But back to Boeing Portland Fabrication, it's not really well known, but there's actually a Boeing site in Portland, and they're called Boeing Fabrication. There's about 18,000 employees, and what we focus on is precision machining, electrical systems, interior, and some composite structures as well, but primarily machining. Fabrication is about a $5.5 billion business and is roughly distributed all over the U.S. And other countries. We have 11 sites in 3 countries from Australia, Canada, U.S., Montana, Oregon, South Carolina, Utah, and Washington. And currently we make about 9.6 million parts and assemblies every year, which is about 800,000 per month. These are the different sites in Oregon. We have a Gresham site, which is the site I work at. Boeing paint hangar we have in Situ, which was recently acquired. They're known for their drones. In Hood River, Dalles, Arlington, and Boardman. We have light marine aviation applications in in Portland and Wilsonville. We also have some other services, AVL. I'm not as familiar with that. And this is the Boeing Portland site. So there's about, I think, over 1 million square feet of building space in the Portland site, roughly distributed between 3 different buildings. And, fortunately, Portland has always been a sub-supplier of Boeing, so we were later acquired in, I think it was, 1974. But the site had existed from 1916. Oh, wait, that's the Boeing. Oh, that's right, 1923. The original Boeing Portland site was the Iron Fireman Stoker Cool Factory. So we initially started machining and manufacturing fire stoker ovens so that people could heat their houses without having to refill coal. So that was the start in Portland. And then you have the rest of the timeline for major plane programs. Boeing Portland overview. So we make approximately 6,100 different types of parts, quite a bit of square footage. The products we manufacture are, for example, just to list a few, are flight actuation, integrated structure, systems, pilot flight controls, and there's various manufacturing processes affiliated with that. But the key emphasis is that Boeing Portland makes flight critical parts. So if you look to the right with that white beam, that's actually called a it's a sided body cord. So that's a titanium forging machined down into a rib structure that's not exactly straight, but is built to withstand enough forces to keep the wings attached to the plane. And so we call those flight critical parts because those are the parts that absolutely need to function in order to keep that plane in the air. Another example of like a flight critical part is a landing gear beam, and I believe that's the first gray picture to the left. And that beam is built to sustain all the forces once a plane lands. So it's normally the first part, or what you hear on a plane that kind of lowers on itself, and then you hear the compression of the landing. We also make engine mounts, which keeps the engine bolted to the plane, which is very important. And then we have some other products listed like flap tracks, flap supports, landing gear beams, but I won't spend too much time going through it, just a long list of parts that are made by the Portland site. And then we also support the plane programs for roughly 6 different programs. So all of our parts are made to accomplish the orders for each plane program. And we currently project every 3 to 4 years there's a new plane program that we incorporate into our new system. And so what affects our market drivers are, of course, market liberalization, fuel price, airline capabilities, infrastructure, emerging markets, environment, growth, airline strategies and models, and high-speed rail. So these are all components that affect commercial airline pricing. And as a result of increasing market liberalization and globalization, there is an increased demand to travel internationally, which has been good for commercial aerospace. And so here you'll see the trend of upward movement. But of course, that also comes with the added consequence of being more cost effective, as there's more competitors in the market looking to engage in more market share to partake in that growth. So roughly, these are our sales according to different types of plane programs, from regional jets, which are smaller, tend to be private, single aisle, small body, medium wide body, and large body. Large body flights tend to be more for international trips. So as you can see, Asia is the newest emerging market that has fueled a lot of the sales. Oops, I closed it. All right. And we also have our fleet change, ranging from most of our sales is currently in single aisles, a few in the large bodies. We're shifting that dynamic based off of what the market forecast tends to project. And, within Portland, they do a lot of cool programs like NECOP, which is mentoring college students for 6-month rotation programs. I think that's Oregon specific. There's the Tech Prep programs, which cater to apprentices that come in, generally after high school, to start opportunities such as machining, maintenance and electrical apprentices. And there's a few internship programs as well, assembly and machining. So that's just a short introduction. And, we are a diverse workforce. So, these are the different languages that are on the Boeing Portland site, written from the Boeing Portland team. And that pretty much wraps up my presentation. Any questions or questions?
I was just wondering where the Portland site was.
Yeah, so it's like way off on the Gresham side, about just before Hood River. I'm trying to think of any noticeable landmarks, but it's well past 82nd Division, 3 exits down from all I remember.
It's kind of like when you feel like you have now exited Portland, you got 2 more exits and then you get off.
Yep, that's pretty much it. So it's not very well known because of the distance, but still considered Portland. I think it's 19,000 Southeast Sandy Boulevard. Yep. Question?
In the last slide, it showed robotics. What career could robotics be used in?
Well, I think there's been a couple of different talks from the previous presenters about how robotics are used to replace an existing, like a little bit of a labor workforce, higher precision. So it can be used for many types of functions. I mean, on a very basic level, when you look at Amazon, they have an automated fleet. I mean, you have little robots driving in set places, moving and storing packages. So it's whatever you apply your imagination to. I mean, sometimes they're used to guide people or they're interacting with people, but I would encourage you guys to continue exploring the industry of robotics if you're interested. So for me, we use robotics like for precision machining. Anything where you have a type of advanced movement, carrying, packaging, moving is still considered robotics. So, I mean, your car is technically an automated moving vehicle, so keep thinking about it.
I know you said you had internships and programs for college students, but do you have any for like high school students?
They're slightly less specific. I think there's the tech prep programs targeted for the audiences that want to become electricians or like mechanics or CNC machining operators. And I think that requires like some level of interest in application. But I think it depends on what you're trying to get into. Is it science or engineering or like a trade?
Probably more engineering.
Okay. Well, engineering internship programs are a little bit more rare. I would encourage, looking into those opportunities more once you're in college because those tend to be more abundant then. Because like the focus is like students that are generally selected for internship programs, which ironically are more selective than jobs. Generally what we're looking for is people that are in programs who are looking to learn a little bit more. And I would recommend the MECOP program where you're taking a little bit more time off and you can spend more time in an industry, like 6 to 5 months. And so when I was in college, I took 5 months off to, go to academia, write papers, and then also go into industry, which I found to work out fairly well for myself.
Okay, I think we have one more speaker today, so we are going to say thank you very much.
Okay, thanks.